This is lecture number 129 in the ABCs of Communism series, and this set of lectures is in support of forthcoming volume 8 on communism in North America prior to white contact. And our subject this morning, therefore, will be the very first Americans, and that'll be in chapter 111 of your textbook when you get it. Now, it was late May in 1969. Excuse me. I'm going to start over again. It was late May in 1969 when our lead vehicle in my Ice Mountain Archaeological expedition pulled onto the old fish house site on the Tahltan River in northern British Columbia. Now, geographically, we were at the confluence of the Tahltan and Stikine rivers. Socioculturally, we were a century into the past at about the time of white contact in this part of the Canadian subarctic. Now, geologically, we were near Canada's only active volcano, known to the Native American Tahltan people as Ice Mountain, and on the white man's maps is Mount Izaysa. Now, I had been accepted into the graduate program at the Department of Archaeology at the University of Calgary in 1967, and at that time, Professor Richard G. Forbes, in his congratulatory letter to me in Los Angeles, had asked where I wanted to specialize, and I had responded in the far north. Now, when Rachel and I had arrived in Calgary at the end of August the previous year, that is 1968, he told me that the only specialist they had in the far north, Richard S. McNeish, had just left Canada. He had gone to Andover, Massachusetts to take up a far less financially lucrative appointment at Phillips Academy. However, it had the research funding McNeish wanted for his projects in Mexico and Peru at the R.S. Peabody Foundation, headquartered on that ruling class prep school campus. Now, meanwhile, Forbes had arranged an office for me with Brian Gordon, who was a graduate student specializing in the far north. And he had arranged with Charles Borden at UBC in Vancouver to be my external examiner. So in my first year at Calgary, Gordon introduced me to an area of Canada I had not previously considered, and now we were there. In the way of preparation, in addition to my heavy course load, Brian had schooled me in the ways of the far north, and he had been kind enough to share with me the results of a preliminary survey he had conducted in the area of Telegraph Creek, British Columbia. He had returned with bags of obsidian tools he had collected from surface scattering sites between Telegraph Creek and the old fish house site where we had now arrived. Now, fortunately, the Indians had not collected these obsidian flakes, blades, and tools for their own reasons. No white people had been up there to collect anything, with the exception of one graduate student from Alaska named Bill Workman. And using Brian's field data and maps from the Geological Survey of Canada, we had located already 5 areas we wished to test for the presence of artifactual remains in stratigraphic context. That is, we had located them with aerial photographs and on topographic maps, all of which we were able to get from the Geological Survey of Canada, which was just about half a mile down the road. Now, the first of these was the old fish house site itself that had the remains of the last 200 years, ranging from projectile points of obsidian and bottle glass and Chinese coins from the earliest foreign contact. Now, I'm going to skip to the 2 most important finds we made that summer. And we have discussed this before in previous chapters and lectures, so I won't have to go into as much detail, but just to refresh your memory, the first was at a site that contained a complete set of obsidian microblades and microblade cores, and that discovery was the result of a lead given to us by former Tahltan chief John E. Carlick. Now, he took us to a site where he said he had been born and raised when there was about 2,000 people in his village. There, in a 4.5 2x2 meter pits, and in the top 10 centimeters, we had found what turned out to be a complete Kobayashi tool assemblage. And I just pulled this book out of the bookcase this morning. My textbook, published in '67, has pictures of that excavation and the location of the site and this complete toolkit. And as I say, we've gone over this before. So what I'm doing here is refreshing your memory. Now, but these weren't the very first Americans. This was a second wave, and I'm going to get to that now. But the obsidian dating on these was done by Leslie B. Davis, who's now passed away, but at that time was a graduate student. And he used a laboratory at Pennsylvania State University in obsidian hydration to do the actual sectioning of the tools. Now, I wrote my doctoral thesis about that assemblage, and photographs have been published in the Journal of Field Archaeology, and as I say, in my textbook, Foundations of Archaeology. Now, the second most important find we made was on a terrace about 100 feet above the old fish house site. Now, this was an ancient terrace made much earlier than the one we had camped on. And on it we found, and in it, we found completely different type of tool assemblage. There were no obsidian tools at all, but there were basalt tools, including one nicely made large blade tool and some fragments of similar material in direct association with an old fireplace. Now, dating would have to be geological and typological, as the charcoal in the fireplace had been inundated countless times by rain and snowfall, as well as rootlets and rodents. So later I would conclude that this represented the first, or at least much earlier, occupation route of people from Northeast Asia. And I think this is the earliest remnant of that migration across the Bering land bridge, or one of them anyway, or highland hopping along the North Pacific coast of people entering the New World. And along with a graduate student, Valerie Harrison, I published a report on this assemblage in the Journal of Field Archaeology. Now, from whence they came. These first Americans came from Northeast Asia. I think we can define at least two waves of immigrants. The first wave we had come across on the Taltan River ancient terrace site that I just discussed. And the second wave is represented in John Carlick's village site with its complete Kobayashi toolkit. Let us look at the geography of Northeast Asia. Now, Siberia borders in the west on the Urals Mountains. From there to the central Siberian highlands and the basin of the Lena River, we arrive at the northeast Siberian highlands. And during the ice ages, the fauna and flora of the northeast Siberian highlands continues all the way to Alaska across Beringia. Now, during interglacials, when the ice recedes and the oceans rise, Beringia becomes increasingly waterlogged and eventually submerged, so that the eastern frontier of Siberia is much the same as it is today. So Beringia is the name we give to that part, which is now the Bering Straits, when it's above water, when it's land. That is, it has a coastline with the fauna and flora associated with the far northern hemisphere. Now, the climate in Siberia is variable. Rakusha, northeast of the Lena in the winter, is among the coldest places on Earth. Rainfall is very low all the time. This is true of the southwest as well, where steppes, deserts, and semi-deserts border on one another, southwest of Siberia. Now, the climate situation is responsible for the different biomes of the region. In the northernmost section, there is tundra with minimal vegetation. Before the beginning of the Holocene, about 11,500 years ago, the tundra extended much further south, and an ice sheet covered the Urals and the area to the east of the lower Yenisei. Today, the largest part of Siberia, aside from the mountainous regions, is taiga, that is northern coniferous forests. In the southwest, this becomes forested steppe, and even further south, it transitions to grass steppes and the Central Asian desert. During the North American Illinoisan glaciation, an ice sheet some 2 miles thick covered the northern hemisphere rather continuously. Now, in Siberia, it was gone by 100,000 years ago, or what is called a Sangamon interglacial in North America. That Sangamon period lasted until about 70,000 years ago, when the ice sheets began to reform. Now, these are called Wisconsin in North America. The ice lasted through its maximum extent in southern protrusion and in thickness. that occurred about 22,000 years ago. And after this, the Wisconsin glaciation began to melt, and it ended altogether some 11,500 years ago. Now, the sea levels again began to rise, and the connection to Siberia to Alaska that we call Beringia was resubmerged. Now, there's a 2010 excellent documentary movie streaming on Netflix called Happy People, A Year in the Taiga, and you should watch this story about the village of Bakhtia in central Siberia on the Yenisei River. Many of the diagnostics of primitive communism have been carried over into a pre-modern communism form, and for all these reasons will be helpful in understanding this particular chapter. Now, primitive communism in the form of Lower Paleolithic archaeological sites litter the Siberian landscape between East Kazakhstan to the Altai Republic. And a Neanderthal child burial was found at Tashiktash, Uzbekistan in 1938, along with tools that show similarities with the Mousterian artifactual assemblages of Iraq and Iran. Now, primitive communism continues in the Upper Paleolithic archaeological remains in the Urals Mountains. Petroglyphs depicting mammoths are found on the Altai River and on the Upper Yenisei River west of Lake Baikal. You'll recall that by primitive communism, we're referring to the technology, the technological component of culture, not to the social organizational component. At any rate, the petrographs are found dating to 25,000 BP, before present, on the shore of the Laptev Sea, north of the Arctic Circle. Now, similarly dated remains of huts have been found in the settlement of Malta near Irkutsk. Sculptures of animals and Venus figurines of women date to the Siberian Upper Paleolithic, and in the post-glacial period, taiga or swampy coniferous forest occurs in the high northern latitudes, especially between the tundra and steppes of Siberia and North America. Microblades and microtools appear in the Upper Paleolithic and continue through the Siberian Mesolithic. In Siberia, from 7,500 to 5,400 BP, archaeological sites feature the introduction of pottery. Southwest Siberia, by 5,000 BP, witnessed the introduction of copper working. And this is far later than the period that we're particularly interested in right now, which is the people who were hunters and gatherers from the time of their very first arrival in the Americas. That hunting and gathering Lower Paleolithic mode of production lasted until the Middle Paleolithic, when broad-spectrum wild resource exploitation was extant throughout Northeast Asia. Now, south of Siberia is Mongolia. At 603, actually almost 604,000 square miles, Mongolia is covered by grassy steppe with mountains to the north and west and the Gobi Desert to the south. Ulaanbaatar, which is Mongolian for red flag, is the capital and largest city. In 1923, the Roy Chapman Andrews expedition of the American Museum of Natural History in New York arrived in Mongolia. Now, he returned with many microblades and microblade cores, some of which were lost until I found them at the Field Museum in Chicago. At any rate, Homo erectus probably inhabited Mongolia, but fossils of erectus have not yet been found there. Homo sapiens did occupy Mongolia by 800,000 years ago. We know this because stone tools have been found in the southern Gobi dating back that early, that is to 800,000 years. And globally, in this presentation, I assert that all humans had advanced from their erectus stage to their sapient stage by 1 million years ago. Another way of putting it is that all humans had cubic centimeter cranial capacities of 1,500 cc's by that time. Now, these people were hunters and gatherers from the time of their arrival. That hunting and gathering Lower Paleolithic mode of production lasted until the Middle Paleolithic, when broad-spectrum wild resource exploitation was extant. Microblade and microblade core makers of the Upper Paleolithic occupied all of Mongolia. They were broad-spectrum wild resource exploiters of land and lake, dwelling plant and animal species. Their remains constitute part of the Northeast Asian, Northwest American microblade tradition, or NANAMT, N-A-N-A-M-T, which covered all of both those areas in the Upper Paleolithic and Lithic times. that is, of the Old and New Worlds respectively, where we use those terms as equivalents. Now, in June of 2016, Polish and Mongolian researchers found stone tools in the southern Gobi Desert. These they describe as highly diversified forms of objects and the varied techniques of working stone that prove that certain locations were repeatedly colonized. Joseph Sokolsky of the Wrocław University says the oldest dates to the Middle Paleolithic are between 200,000 and 40,000 years ago. The lakeshore site components were deposited when wildlife was abundant. The team also recovered 11 jasper artifacts, which were dated to about 40,000 years ago. In the Upper Paleolithic, that mode of production was perfected in the form of microblades and cores, so we have proof there of continuity. The Himalayan and Greater and Lesser Khingan Mountains block the warm and wet air from penetrating Northeast Asia. Even so, the climate was more humid hundreds of thousands of years ago than it is today. Now, as for the crossing itself, the land area connecting Northeast Asia and Northwest America is called, as I have said, Beringia. It was westerly bounded by the Lena River in Russia. Easterly, it was bounded by the Mackenzie River in Canada. It extended north to 72 degrees north latitude, bordering on the Chukchi Sea, and on the south it extended to the tip of the Kamchatka Peninsula. Beringia included the Chukchi Sea, the Bering Sea, the Bering Strait, the Chukchi and Kamchatka Peninsulas in Russia, as well as Alaska in the United States. During the Pleistocene ice ages, like most of Siberia and all of North and Northeast China, it was not glaciated because snowfall was light. It was a grassland steppe stretching for hundreds of miles. Now, as for its role as the road into the New World, during Pleistocene glaciations, of which there have been 5 in the last 4 million years, Beringia formed the Bering Land Bridge. It was 620 miles wide, covering 620,000 square miles. Another way of thinking about its size is that it was as large as British Columbia and Alberta together. Now, across this bridge, Paleolithic people moved into northwestern North America by 100,000 years ago. Initially, they found their passage eastward blocked by a huge sheet of ice, until a temporary recession in the Wisconsin glaciation opened an ice-free corridor through Alberta. Then people made their way further south so that they arrived in Brazil by 70,000 BP, and along their way they left many archaeological remains in North and South America. Now, band-organized primitive communist human populations moved across this entire Beringia area from Illinoisan times until the historical era. I consider the ancient Tahltan River terrace site discussed above to be evidence of one early migration. My doctoral dissertation presented proof of another later migration that had originated in northern China, Mongolia, Siberia, and northern Japan, and as we have seen, descendants of these people arrived in northern BC by 9,500 years ago. Alaska witnessed all 5 major Pleistocene glaciations and a multitude of minor ones. During Pleistocene glaciations, it had a cool climate and corresponding environments. During interglacials, Alaskan climate varied from Arctic and subarctic to alpine and subalpine to subtropical, and interglacial Alaskan climates varied from Arctic and subarctic. Interglacial low sea levels exposed the land bridge connecting it to Siberia. Early humans and the humans they hunted crossed this bridge. Now, archaeologists have excavated their remains and those of then contemporary local wildlife, including butchered woolly mammoths. Ethnographic Native Americans interpreted local fossils mythologically. Some of these local fossils had attracted the attention of formerly trained scientists by the 1830s, and major local finds include the Kikak Tegosiak Pacranosaurus bone bed, the Pleistocene-aged woolly mammoth, Mammothus primigenius, is the Alaska state fossil. In 2017, Chinese scientists announced that they had recovered and reconstructed the entire genome of a woolly mammoth. Their research awaits permission to go to the next step, which is insertion of the mammoth DNA into the egg of an East Asian elephant. Exactly the kind of procedure that you saw in Jurassic Park, which was, of course, fictionalized. The people who hunted them were primitive communists, organized as bands, eventually as tribes of hunter-gatherers. They fanned out south of the continental glaciation that covered Canada and much of what is now the lower 48 United States, and spread throughout the rest of the continent. Meanwhile, in Beringia, with the inundation complete after the last ice age, the only land still visible is at its center. These mountainous protrusions are the Diomede Islands, the Pribilof Islands, St. Lawrence Island, and King Island. Today, early Alaskans are divided into several main groups: the southeastern coastal Native Americans, the Tlingit, Haida, and Tsimshian, the Athabascans, the Aleut, and the two groups of Eskimos called Inupiat and Yupik. Now, prehistoric Siberia had several archaeologically distinct cultures. Then the ethnographic cultures of western and southern Siberia were pastoral. Those of the eastern taiga and the tundra were hunter-gatherers. Nomads emerged in the Central Asian steppes about 3000 BP. On the Diomede Island site, according to the U.S. Census Bureau, the village has a total land area of 2.84 square miles. Little Diomede is located 25 miles west of the mainland in the middle of the Bering Strait, and it's 2.4 miles from the Russian Big Diomede Island. But Alaska was connected to Siberia by the Bering Land Bridge. Little Diomede was a part of that bridge. The first visitors there came by foot on the bridge and on top of the sea ice. As the sea level rose, driftwood and whale skin boats were used for visiting Big Diomede Island. Well, whale hunting, fishing, and mainland occurs all through mainland Alaska and Siberia. Now, Anagula is the oldest archaeological site in the Aleutian Islands. The Anagula Archaeological District National Historic Landmark is on the tiny 1.5 mile long Anuliak Island, or Anagula Island, of the Aleutian Island chain. The Anagula Archaeological District consists of two pre-contact sites: the Anagula Village site and the Anagula Core and Blade Manufacturing site. The latter sits atop a bluff that provides a view of fish, sea mammals, and passing boats. A ridgeline protects the site from strong Aleutian winds, and the core and blade side of Aguslia means the place for making stone blades is around 9,000 years old. It represents one of the earliest known human occupations in the Aleutian chain and the earliest known ancestors of the Unangan or Alaskan Aleut. The core and blade site covers an extensive horizontal area. The most common stone tool making technique at the site produces long, narrow blades which yield polyhedral shaped cores. Many of the blades are retouched with finer flaking perpendicular to the edges to create a sharper blade. In some ways, these are similar to the microblade core and microblade technology found in Northeast Asia and at Telegraph Creek, BC, but without the distinct Kobayashi System A. And this important relationship needs to be worked out. Much of it, of course, is underwater. Now, other stone tools include scrapers and abraders. These tools are fashioned from chert, shale, basalt, and andesite, and obsidian, none of which is available in the immediate area. Another curious feature of this specialized manufacture site is the absence of hammerstones. The absence of striking tools at this manufacturing site leads to three possibilities. First, the same material of the blades was used for striking tools. Second, organic materials used as hammers have decomposed. And third, the artists carried their tool-making tools away with them when they left the factory. The core and blade factory is covered by multiple layers of ash, from the Akbuk volcano, in some places up to 6 feet thick. The technology of the Isagula core and blade volcano at Anagula, in some places, is the same as the Upper Paleolithic and tool technology of Siberia. DNA studies have been done on contemporary Aleutian Islanders and on the skeletal remains of their pre-contact ancestors, and these prove both continuous contact and incursion of DNA from the eastern Aleutians. The village site was built on an even higher sea cliff than the core and blade site and has views of Nikolsky Bay and Umnak Island, climbing ridgelines surrounding the village on the north and west, protecting it from the wind. The large ancestral Anangula village site is younger than the core and blade site. The Anangula village site was built on a bluff over 70 feet above the sea, and here are remains of dozens of semi-subterranean houses, storage pits, tool scanners, and a few densely packed midden features. Another smaller village site of the same age is on the opposite side of the island from the main village, and the smaller village was a seasonal camp used by people from the main village. At the main village sites, archaeologists have recorded up to 24 depressions in the ground that are the location of house ruins, and many more depressions revealing the location of storage pits. The houses are arranged in 3 kinship unit reflecting rows along the edge of the bluff. This is the same pattern as recorded at the Tahltan River ethnographic village site number 2 of the Ice Mountain Archaeological expedition. A small stream supplying fresh water runs down the cliff face to a narrow beach below. Only 6 of these 3 houses have been excavated. 6 of these houses have been excavated. Each of these is semi-subterranean and roughly rectangular ovoid in shape. These range from 13 to 20 feet across and 20 to 30 feet wide. Archaeologists have also excavated some of the contents of a midden feature. On a slope at the edge of the village are additional archaeological remains. These have stone paved floors and narrow trenches on 2 sides that meet to form a V shape with the point of the V on the uphill side of the ruin. The V-shaped trenches drained moisture from the floors. These structures were used as food storage facilities, especially for a root plant called umkan. This is proof of the broad-spectrum revolution. Anangula village was buried beneath deep layers of volcanic ash that have grown over with ryegrass and monkshood. The ash layers protected the site from wind erosion. Archaeologists found hammerstones, anvil blades, scrapers, retouched blades, and tools made for right-handed or left-handed use. These artifacts were preserved in their original positions at the time of the ashfall. Outside the houses are several intact stone tool workshops where thousands of stone flakes had been left behind by these ancient craftspeople. 20,000 artifacts were recovered from less than 1% of the site area. The Aleutian chain faces the Bering Sea to the north and the Pacific Ocean to the south. The archipelago follows the arc of the Aleutian Trench, where the Pacific Plate meets the North American Plate. The Aleutian Islands encompass 52 volcanoes, 27 of which are active. Analuliak Island is within the Alaska Maritime National Wildlife Refuge, and migratory seed birds nest in the rocky cliffs of the island, while imported rabbits roam the grassy slopes of the island. Now, next we come, of course, to Alaska, where the Kobuk River headquarters are in the Brooks Mountain Range. This 200-mile-long river runs through a landscape of birch, spruce, poplar, and willow, well above the Arctic Circle. Finally, it rolls through the frozen tundra as it nears its Chukchi Sea destination. The summers are short and ice-free. This remote Kobuk Valley has been home to people for millennia. Their first houses were dug into the ground with above-ground extensions. Some of these house pits have been excavated about midway on the Kobuk River at the site of Onion Portage. The first Americans camped here. It was like New York to settled and incoming generations of arriving Europeans. Their economy was broad-spectrum wild resource at Onion Portage, and it evolved as it evolved over preceding several 100,000 years in Northeast Asia, this time featuring a concentration on the herds of caribou that were funneled through this bridge in their annual southbound migration, and on the onions, wild onions, which flourished there. We know them archaeologically and among the artifacts they left behind in these homes, and our jade tools and weapons. The jade is found in the form of river nodules washed down from Jade Mountain. 150 miles from Kotzebue is Jade Mountain, which is made of beautiful dark green jade and is one of the westernmost peaks in the Brooks Range. In China, this jade is called Heavenstone. We excavated an adze made of it at the Tahltan River Old Fish House site in 1969. Alaska's thousands of summer tourists leave homeward bound with jewelry and trinkets made of Alaska jade from that remote valley. At any rate, Onion Portage features a proliferation of wild onion species, giving its name by the descendants of the first arrivals whom live there today. Louis Giddings, then of Brown University, made a surface investigation of the house pits at Onion Portage before World War II. In the 1960s, he returned and began to work at the site in earnest, and by 1963 a large crew of scientists and helpers were working with him at that site. They were carefully uncovering layer after layer of habitation and collecting the artifacts of each layer's exposure. Onion Portage was, and may still be, the oldest human campsite so far known in Alaska. In one of Giddings' several books, he also tells of finds at Cape Krusenstern that now is a national monument on the Arctic Ocean coast just north of Kotzebue. This site of ancient populations is quite large, indicating a large population, proving again that peoples of the Upper Paleolithic in Siberia, what we call Upper Lithic in North America, were very competent, broad-spectrum wild resource exploiters. They would have had a lot of time on their hands, which, like all cultures of this mode of production, would have been spent thinking and talking about their environment in supernatural as well as natural terms. Acting on these beliefs includes proof found in one Krusenstern site where the ancient skeletons had ivory spinal columns holding the vertebrae together, and with eye sockets filled with ivory eyeballs. And that brings us to the Broken Mammoth Archaeological Site, the bottom layer of which dates to 13,500 BP at the end of the Bridge period. Now here were found biface tools, microblades, and microblade production spools. The site overlooks the Tanana River Valley of interior Alaska. Excavations have revealed three distinct occupations. The oldest hearths date to 12,200 BP. This was the site of temporary seasonal hunting and fishing. A small bone needle was found at one of these hearths. The totality of evidence shows that small band populations built this and other camps of the Nenana complex. Three sites in the Tanana River Valley date to this period, and these are the Swan Point site, the Mead site, and this, the Broken Mammoth site. Above these stratigraphically are remains of the Chindan complex of stone tools. The Chindan complex dates from 13,500 to 13,000 years ago. The stone tools from this period are small, triangular, or teardrop-shaped bifaces, usually made of thin flakes and often poorly edge-flaked. The Chindan complex is present at the Broken Mammoth site, where a few flakes and bones are dated to within this period, and no microblades. Artifacts found at the Broken Mammoth site in Cultural Zone 1 include a lanceolate-shaped projectile point, retouched flakes and in side scrapers, point and point fragments, flake burins, burin spalls, microblades, and microblade cores. Burins are carving pieces of stone used to carve wood and bone. The material that these artifacts were made from include rhyolite, chalcedony, chert, basalt, and obsidian. The obsidian originated from Batsatena in northwest Alaska and from the Wrangell St. Elias National Park and Preserve in East Alaska. Cultural Zone 2 has only produced a few flakes, fire-broken rocks, and hearthstones. Microblades have yet to be excavated closer to the bluff edge. Excavations in Cultural Zone 3 at the site have yielded many tiny flakes, retouched flakes, larger biface fragments, points and point fragments, hammers made of quartz and anvil, a small-eyed bone needle found associated with a hearth that radiocarbon dates to about 10,300 BP. The bone needle means that the occupants used this site to process skins to make clothing. Debris from the making of tools has been found in Cultural Zone 4. The debris is composed of rhyolite, basalt, obsidian, chert, and quartzite, implying that the occupants of the site carried out some manufacturing and/or repair of tools. Artifacts at this zone include retouched flakes, scrapers, and a large quartz chopper scraper plane. In addition, several ivory tusk fragments with scratches that came from stone tools have been found. One tusk fragment has a stone microchip embedded in one of the scratches. A tool cache was also found with ivory artifacts, 2 projectile points, and a possible handle. One of the ivory fragments from this cache was radiocarbon dated to 15,800 BP. The age of the ivory suggests that the occupants brought it from a much older kill site. The obsidian used at this site came from Wiki Peak and is dated as early as 13,400 BP. The same obsidian was also used at the Walker Road site. The Moose Creek site in the same area dates earlier than 13,000 BP. The discovery of the Broken Mammoth site establishes that human occupation of central Alaska began before 11,000 BP. Artifactual evidence proves humans occupied parts of central Alaska before 13,500 BP, and people had to have lived in the region even earlier, given the probable early Sangamon interglacial site at the confluence of the Tahltan and Stikine rivers in northern BC. The obsidian artifacts discovered in Broken Mammoth prove earlier occupation in northwest and east Alaska. The Broken Mammoth site offers excellent preservation of remains of the animals, providing insight into the hunting methods and food resources utilized by these early people in North America. Early occupation of the Broken Mammoth had a setting similar to the lowland tundra, with low vegetation, mostly shrubs, and a few trees. The regional pollen record provides evidence of shrubland with plant life, including dwarf birch and willow. After 9,000 years ago, this shrubland became woodland, which supported spruce and alder trees. The faunal remains of a red squirrel and a porcupine date the process of forestation and a little over 9,500 years ago. Windier conditions reestablished at Broken Mammoth around 10,000 BP, with loess accumulation accelerating until 7,800 BP, and modern climate stabilized after 5,700 BP. The stratigraphy at Broken Mammoth is well preserved and is one of the primary factors that have established the age of the site. The site consists of wind-deposited sand and loess overlying weathered bedrock of the Yukon-Tanana crystalline terrace. Now, these deposits are divided into 4 units, A, B, C, and D. In your textbook, I go into that in detail. But for our purposes, we can say the oldest layer being is Unit A, composed of fine sand, dating at 12,000 BP. Units B, C, and D are also made of wind-blown silt or loess. Unit B contains 3 different paleosols, that is, ancient soils. B1 is 11,200 BP to 11,800. B2, 10,300 to 9,300. There is no direct dating for B3, and Unit C dates sometimes after 9,000 BP, and the final Unit D is an accumulation of silt deposits over the last 9,000 to 8,000 years. So, large mammals, fish, and waterfowl provide a broad spectrum of plentiful, exploitable wild resources, especially when one remembers that avian fauna was extremely diverse, including mallard, teal, swan, and geese. The Broken Mammoth site has remains of large animals including mammoth, elk, caribou, and bison. Furthermore, hunted or scavenged people had access to mammoth ivory. Radiocarbon dates on some of the fossilized ivory tools run from 20,000 to 18,000 BP. On their hearth charcoal, that dates to 13,525 BP. Anyway, these people were organized into highly mobile bands that moved seasonally over the landscapes, exploiting the various resources and wildlife. The interception of the various migratory routes of herd of bison and elk and migratory birds was the strategy that may have required a commoditization of their labor power occasionally. People had the technology for hunting mammoths, but they probably killed one mammoth in a lifetime and never stopped talking about it. As I say, the ivory tools made from mammoth tusks was probably scavenged. Now, at Swan Point Archaeological Site, which is located in eastern central Alaska in the Tanana River watershed, the sites provide evidence of megafauna that no longer exist in Alaska, including extinct varieties of elk, bison, and mammoth. Artifacts of the Swan Point site have been given radiocarbon dates of 14,500 years BP. Swan Point has been occupied at least 5 times since then, and is the oldest known site in the Tanana River Valley. The oldest cultural level dates from 11,600 to 10,000 BP. Artifacts found include worked mammoth tusk fragments, microblades, microblade core preparation flakes, blades, dihedral burins, red ochre, pebble hammers, quartz tools, and choppers. A variety of bifacial points were found at this level, and they date approximately 10,230 BP. They include lanceolate points with convex to straight bases, along with graver spurs, quartz pebble choppers, and hammers. The mammoth ivory artifacts found in the latest Pleistocene zone date to about 14,000 years ago and were scavenged elsewhere. Which brings us to the Yukon. The Yukon covers 186,000 square miles in northwest Canada. Alaska borders it to the west, the Northwest Territories to its east, British Columbia to its south, and the Arctic Beaufort Ocean to its north. The Yukon abounds with snowmelt lakes and Canada's highest perennial white-capped mountains. Its ragged eastern boundary follows the divide between the Yukon River Basin and the Mackenzie River watershed to the east in the Mackenzie Mountains. Except for the coastal plain on the Beaufort Sea coast, most of the Yukon is part of the American Cordilleran mountain ranges, plateaus, and river valleys. The Yukon's climate is Arctic north of Old Crow. Then it becomes subarctic between Old Crow and Whitehorse. The long sunshine hours in the short summer allow a profusion of flowers and fruit to blossom, especially in the more humid southeast. Otherwise, the Yukon is boreal forest until, except in the extreme north and high elevations where tundra becomes the main vegetation. Permafrost is common. The northern part of Yukon has continuous permafrost, while it is widespread in the central part. Even the southern Yukon has scattered patches of permafrost. That is, ground that's frozen all year round. Now, the Kluane ice fields in Kluane National Park and Reserve are the largest non-polar ice fields in the world. The Kluane National Park also contains 8 of Canada's 10 highest mountains, including the 5 highest, all in the St. Elias Mountains. A number of glaciers flow out of the ice fields, including the Logan Glacier, the Hubbard Glacier, and the Koshkowushki Glacier. Now, the Denali Fault and the Tistina Fault have created major valleys called the Shakwat Trench and the Tintina Trench. The former separates the Kluane Mountains from other mountain ranges north of it. The Haines Highway and the Alaska Highway north of Haines Junction are built in the Shakwat Trench. The Tintina Trench bisects the Yukon from northwest to southeast, and its edges have rich mineral deposits, including the Klondike gold and lead zone zinc deposits near Faro. The volcanoes in the Yukon are part of the circle of volcanoes around the Pacific Ocean known as the Pacific Ring of Fire. The Yukon includes more than 100 separate volcanic centers that have been active during the Quaternary. The Fort Selkirk volcanic field in the central Yukon is the northernmost Holocene volcanic field in Canada, including the young, active cinder cone Volcano Mountain. A volcanic field in south-central Yukon is called Alligator Lake Volcanic Complex. It contains two well-preserved cinder cones that cap a small shield volcano. Lava from the cones traveled north and erupted at the same time. Volcanoes in southwestern Yukon are part of the Wrangell Volcanic Field, which is related to the subduction of the Pacific Plate beneath the North American Plate at the easternmost end of the Avalanche Trench. The St. Elias Mountains are part of the Coast Mountain Range that range from southern British Columbia to Alaska and cover the southeastern Yukon. While the St. Elias Mountains contain the highest mountains, there are numerous other mountain ranges from the British Mountains in the far north and the Richardson Mountains in the northeast. Both are part of the Brooks Range. Then we move from the Selwyn Mountains and the Mackenzie Mountains in the east to the Cassiar Mountains in the southeast, the Pelly Mountains in the central Yukon, and the Ogilvie Mountains north of Dawson City and along the Dempster Highway. Most of the territory in the watershed of the Yukon River flows into the Bering Sea. The southern Yukon is dotted with large numbers of large, long, and narrow glacier-fed alpine lakes, most of which flow into the Yukon River system. And the larger lakes include Teslin Lake, Atlin Lake, Tagish Lake, Marsh Lake, Lake LaBerge, Kusawa Lake, Kluane Lake. Bennett Lake on the Klondike Gold Rush Trail is a smaller lake flowing into Tagish Lake. Rivers flow into the Pacific Ocean or into the Arctic Ocean. The Alsek-Tatashini drainage flows directly into the Pacific from the southwest Yukon. A number of rivers in northern Yukon flow directly into the Arctic Ocean. The two main Yukon rivers flowing into the Mackenzie River in the Northwest Territories are the Liard River and, in the southeast, the Peel River and its tributaries in the northeast. Subarctic Köppen Climate Classification DFC characterizes the long cold winters and brief warm summers. There is an airstrip at Snag, which is 15 miles east of Beaver Creek, near the Alaska border, that recorded a low temperature of minus 81.4 degrees Fahrenheit on February 3rd, 1947. That's pretty cold. The Arctic Ocean coast has very dry tundra climate with little precipitation. Even so, it is considerably wetter in the southeast. Precipitation is much greater in the mountains, and the snowpack melts well into the summer, resulting in high water in July or August. As we have seen, except for the Arctic Ocean coastal plain and highest elevations, most of the Yukon is boreal forest. Mountain peaks at higher elevations are alpine tundra, while the coastal plain is Arctic coastal tundra. The Peel River area in the northeast is in the Taiga Plains ecozone, and the Arctic coast is in the southern Arctic ecozone. This is a continuation of the central Siberian taiga. The Yukon was and is covered with forests. These trees, being small, took a long time to grow and regenerate in the dry, cold climate. Black spruce, white spruce, quaking aspen, balsam poplar, and Alaska birch are found throughout much of the Yukon. The Lodgepole Pine reaches its northern extreme in the south-central part of the territory, while tamarack groves flourish in the southeast. The subalpine fir occurs at high elevations in the southern part of the territory. Now, large mammals include caribou, moose, wolves, grizzly bears, and American black bears. Higher elevations have Dall sheep, Rocky Mountain goat, polar bears that inhabit the Arctic coast. The mule deer and its predator, the cougar, are common in the south, as are coyotes in the northern Yukon. Elk and bison greeted the first humans arriving. There is a plethora of rodents, including squirrels, ground squirrels, lemmings, pikas, beavers, various voles, porcupines, and muskrats. Mustelids, including the wolverines, marten, ermine, least weasel, American mink, and river otter. occur everywhere. Other small carnivores present are the lynx, red fox, and Arctic fox along the northern coast. More than 250 species of birds inhabit the Yukon. The common raven is the territorial bird and is seen everywhere. Other common resident birds include bald eagles, golden eagles, geofalcons, and peregrine falcons, and are 5 species of grouse. Many migratory birds breed in the Yukon at the northern end of the Pacific Flyway. Other than the cod-like freshwater burbot and the northern pike, most of the large fish found in Yukon rivers, lakes, and streams are salmonids. 4 species of the Pacific salmon, Chinook, sockeye, coho, and chum, breed in Yukon rivers and lakes in the Pacific and Yukon River watersheds. The Yukon River has one of the longest freshwater migration routes of any salmon. Another long migratory reproductive route is through the Stikine River drainage and up the Tahltan River, where my crew and I assisted the local Native Americans in the summer of 1969 catching salmon on their way to spawn. Anyway, Chinook salmon swim 2,000 miles from the river mouth in the Bering Sea to spawning grounds upstream of Whitehorse. There are also landlocked kokanee, that is sockeye salmon, and rainbow trout. Lake trout are present in most large Yukon lakes, as well as Dolly Varden, bull trout, and Arctic char. The Arctic grayling is ubiquitous, while the lakes have various whitefish and inkanu. There are no Yukon reptiles, but there are a few frogs. And for some final comments on northern British Columbia's geography. The vast wilderness of northern BC has 193,000 square miles of area and a diverse ecological geography. The Queen Charlotte Islands extend into northern BC latitudes and have an equally diverse ecology. Ancient old-growth forests grade into coastal ones. British Columbia consists of 2 major continental landforms, the interior plains in the province's northeast, the British Columbia portion of what is part of the Alberta Plateau. The rest of the province is part of the Western Cordillera of North America, often referred to in Canada as the Pacific Cordillera or Canadian Cordillera, and the Cordillera itself is divided into 4 main systems. Some of the earliest American arrivals traveled down the Pacific coast and up the navigable river before building camps. There was an ice-free corridor for most of the last 100,000 years along the margin of the Rocky Mountains from the Yukon through Washington State, and therefore some of the earliest inhabitants of North America arrived in this way. Still others seem to have moved across the northern coastal tundra all the way to the Atlantic coast and then down into what is now the USA. That brings us to a conclusion of this lecture on the arrival of the earliest Americans. To summarize, just let me say that there were at least 2 major waves of migrations. The first one, which occurred when people crossed the Bering Straits probably 100,000 years ago and arrived in Brazil by 70,000 years ago, of which we can find just scattered remains here and there in the rest of the hemisphere for a variety of reasons, which we'll continue to talk about. And the second one is a wave carrying microblade, people carrying microblades from Northeast Asia, which arrived in far northern British Columbia by 9,500 years ago. In North America, or in the Western Hemisphere, as you're about to see, Native Americans, the Indians of today, arose from 3 different traditions that emerged from that very first migration. And we'll bring that subject up as we go along. So that kind of concludes it for this morning. And whenever I get finished with this next chapter, we'll have another lecture.